we can guarantee to have in a trapezoid. Gabby, I'll let you close the door for me, please. Thank you. All right? That's all we need to be able to say we have a trapezoid. So when you do this little sheet, you'll only have one check mark in your little column, and that's going to be one pair of opposite sides. So this is going to be one of the few things that you're going to have on your note cards. Do you want this in your note cards? Because I also have both pairs of sides being, so it's like either one or the other. Okay. All right, what you do want to say, though, is that the angles along the sides, or the legs, equal 180 degrees. So we can't say that adjacent angles add up to 180. We need to say that the angles along the legs. So these two will add up to 180 degrees. They're different angles. And these two will add up to also 180 degrees when we add them up. Does that make sense? Don't go these two. Don't do the ones along the bases. The parallel sides are your bases. The slanted sides are your legs. Okay? All right, now an isosceles trapezoid has a couple of interesting things that you're going to want to put, not so much on this sheet, but you'll want to tell me that in your note cards. Again, you've got one set of parallel sides. And what's going to make it isosceles is what? What's equal? Not the two bases, but the two legs are congruent. And since the legs are going to be congruent, then we'll say that the base angles are also congruent. These are base angles. Those ones will be congruent. And these two up here will be congruent. Yes? Well, I will tell you that the diagonals are congruent. Oh, do we? I don't know. Is that true? She's saying that if this is an isosceles triangle, that when we find the midpoint, you're saying that those are congruent?
Or like, no, if you do it the other way around, so that the two sides go to one.
So this way and this way, you're saying if I go to the midpoint that all three, it could be. Look it up for me. Not right now, but yeah, look it up. So actually, for the fourth information is that the diagonals are congruent, but only in an isosceles trapezoid. Okay? Only in an isosceles trapezoid. Legs are the sides, yes. The legs are congruent. Legs are congruent. Yes. Right. See how, and I wrote it up here. Legs, bases. If you got that on there. Okay. Okay, so mid-segment theorem. Okay. So the mid-segment is right here. It is going to be parallel. This is your mid-segment, MS. Okay. It connects the midpoints of the sides. Okay. They're parallel, so don't we have angles that are congruent along the sides? Okay. I don't think that's right. Hold on, I got one too many here. These two are congruent, yes? And these two are congruent, yes? Because we've got parallel sides cut by a transversal. Okay. And the interesting thing is if I call this B1 and B2, that B1 plus B2's length divided by 2 is equal to the length of the midsegment. So you want to think of taking the average of the bases. And so this is note card worthy. So the sum of the bases divided by 2 is equal to the length of the midsegment. So let me write that out. So the sum of the bases in a trapezoid divided by 2 is equal to the length of the midsegment, MS. Are we okay? What's the matter, Natalie? No, we be nice. Claire, so does that make sense? Did she explain it to you? Okay, great. All right, area formula. Anybody know what the area formula is for a trapezoid? B1 plus B2. I cannot seem to write. Like my brain is one step ahead of what I'm writing. B1 plus B2. Times the height. Okay? So B1, B2, where's your height? What do we need to look for if we got a height? It's got to have an altitude or a height. It's got to form a right angle. So you got to find it, where is that right angle being formed? Okay? On the other side. Sure. Because these are parallel. Aren't they parallel? The bases are parallel. So the height is the same throughout the whole figure. Yeah. All right. So put that in your note cards. Kind of funny how many people forget the formula for a trapezoid. I don't know. I don't know why. All right. All right, here we go. Put a little, yes. Yes? Sure. We could say that a square is a type of trapezoid. Because the only thing, right. Square is everything. Exactly. Well, what is more specific? The square is the most specific. More specific. Here we go. Ready or not, I am continuing on. Now these are, just so we don't get confused, these are individual questions and there's no carryover, all right? So if angle B is 73 degrees, then what is angle C going to be? How do we figure it out? What do you do? Emma? You would take 180 minus 73, and that leaves me with 107 degrees. Correct. Remember, no carryover, so I'm erasing it now. If angle A is 51 degrees and angle C is 105, what is the measure of angle D? What am I going to do here? Isabel? Yep. So we have extraneous information here. So we'll do 180 minus 51. And that would give me 129 degrees. So yes, I was trying to confuse you, and it didn't work. Rats. All right, angle A is 48 degrees. Angle C is 112 degrees. What is the measure of angle CFE? This one. What am I going to do here? Sydney? Yeah, 180 minus 112. And so that's 68 degrees. What else is going to be 68 degrees then? Angle B will also be 68 degrees, right? Because we've got a mid-segment going on. This is a mid-segment. I didn't tell you that, but I'm telling you now. All right. If AB is 28, let me get rid of all of this. So AB is 28, DC is 13, then how do I find EF? And I defined it to be the mid-segment. I'm telling you, it wasn't really written on there. What'd I do, Kaylee? 28 plus 13 over 2 comes out to 41 over 2, which is 20.5. Right? Did I do the math right? If EF is 13 and DC is 6, how do I figure out AB? What would I do on this one? Sarah. All right, what am I going to do now? Who knows what I would do mathematically now? Yes, we don't like fractions. So 6 plus x equals 26, so x is equal to 20. And because I like to make life difficult for you guys and make y'all work, not really. I just want you to use your algebra. If EF is x plus 5 and DC plus AB is 4x plus 6, what's the length of EX? So what am I going to do? Okay, raise your hand. I heard a little. Paige? Sure. And what would I do in this case to solve? I could, or could I go ahead and reduce everything by 2 on the left? I could in this case because it comes out nicely, so it's up to you. 2x plus 3 is equal to x plus 5, so x is equal to, and what does that make EF? 7. Yes. Athena. No, a square is the most specific. Parallelogram is very general. All I need for a parallelogram is opposite sides are parallel and congruent. But I don't say anything about diagonals or, you know. All right, are we good?